Here's a little guidance for solving your stopping distance problem. You're going to go through our normal steps. Force gravity, you are on Earth. You'll get a randomly generated car mass. Set your force gravity to force normal. Use your normal to find your friction. It will tell you a randomly generated road coefficient for the coefficient of friction. Whatever you get for your force friction should go in for your force net. Solve for acceleration. Make sure you make it negative since the car is slowing down. The car is going to stop, so you're going to have a final velocity of 0. And it should tell you the initial velocity of your car. So that should give you your 3 pieces of information that will let you figure out your stopping distance and your stopping time. Hopefully this is enough to help you through the problem. In this problem, you're going to figure out stopping distance, but I want to challenge you by putting this object on a different planet. So you're going to have to use the universal gravitational force formula instead of the simplified version that we use on Earth. But from that point on, the rest of the problem will be similar to everything else that we've done. When you're done, put in your force normal, put in your stopping distance, and hit submit, and see whether or not your answers line up with what they should be. Work carefully, try and get it on your first try. For this problem, you must actively find the coefficient of friction between some tires and a roadway. So this is not one where you're just solving a problem, but you have to kind of set up and collect your own data. So I would suggest working on your Chromebook, so click on the desktop version. It'll tell you the gravitational field and the mass of your car. Your car is not even visible yet, so you're going to click on the start button. You're going to step on the gas pedal. You're going to hold it down till you get to whatever speed you want your car traveling. I'm going to stop at 30. I don't hit the brake until I get to the braking line, which will be marked as 0 meters. At that point, you hold down your brake until your car comes totally to rest. Okay, you can then record your stopping distance. So for mine, it's about 293 meters. I start with my initial speed. Again, I picked what that was. My final speed is 0. I use my equations and get my acceleration. I then go backwards to this formula for Newton's law. I put my acceleration in here, and you can make it positive. You'll get your force net. That force net is going to be your force friction. You're going to use force gravity equals mass times gravitational field. Again, you're not on Earth, but I'm not going to make you go through the long calculation. So I told you the gravitational field. I told you the mass. Take your force gravity, set it equal force normal. You'll have normal from here, friction from here, and you solve for your coefficient of friction. So you're working backwards to experimentally determine coefficient of friction. In this problem, you're pulling a block across a surface. The surface has friction, and you're going to be applying a force the entire time. You need to predict how much time it takes the block to get across the table, and how fast it will be going when it reaches the barrier at the end of the table. So what you want to do is you want to find your force gravity, your force normal, your force friction. The difference is there are more than one force that is acting on the object. You're pulling it and friction's trying to slow it down. Let's say you had a friction of 3.6 and you're pulling at 13.6. That would give you a net force of 10, and that's what you want to plug into your equation. So don't use applied force, don't use frictional force, but use net force to get your acceleration, which you can then use to find time and final speed. Your initial velocity is 0, and the distance you're going to travel is written on your problem. Make sure you change from centimeters into meters. Good luck.